Hey, so today we're going to talk about optimizing area and perimeter. And you'll notice that in the title, this is part one. So we're not going to cover everything that we're talking about for optimizing area and perimeter. Tomorrow, we're going to continue with this same topic. Now, when we talk about optimizing, we are talking about questions like this. So suppose we have a gardener who wants to determine the largest or the greatest rectangular area that can be enclosed by a given length of edging. Or another type of question where it says a dog breeder wants to make a rectangular training pad with a given area, but with the smallest perimeter. Now, all of these mean that there are some sort of constraints. So there are constraints like money or material or space. And so you want to make the most out of that situation. So let's define optimization. So optimization, making the most out of the situational constraints. So for example, money, materials, space, etc. The question that we're working on right now is we have 20 meters of 1 meter fence pieces. Watch the video and record the results. What's the maximum area that you can enclose? So we've got 20 pieces in total, and we have to make a rectangle that gives us the largest area. In this case, the perimeter is going to be the same, but the area will change. So we've created there's a chart already. Okay, so the first one, we have a perimeter of 20. Let's go back to get the length and the width. So length here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the width here is 1. So length of 9, width of 1. We know that area is length times width. So let's multiply that and we get 9. Okay, so the second one, we've now created with the same fence pieces, a length of 8 and a width of 2. Now the area, length times width, we're going to have 16. Hey, same perimeter of 20 units. We've now extended the width so that it's 3. And our length, 1, 2, 3, 4, 5, 6, 7. So 7 and 3. Area is 21. Okay, now width is 4 and length is 6. Area, length times width, we now have 24. Okay, 20 units for the perimeter still. 1, 2, 3, 4, 5 for our width. 1, 2, 3, 4, 5 for our length. So 5 and 5, the area is 25. So we could continue this, but really I don't have to, because I know that things are going to start repeating itself. If I stretch the width to 6 units now, my length would be 4 and I would have the same as I had before. So 4, 6, 24. The next one, we could have 3 and 7. Okay, 2 and 8. And then the last one, we would have 1 and 9. Okay, so we've taken 20 meters of fencing and we have put it into different configurations where we had a different shape rectangle and different areas. Okay, so this is the chart that we just created. Okay, so the conclusion is the middle one that gave us the largest area was the square. Length of 5, width of 5, and our area gave us 25 meters squared. Now, I'd like us to take the information that we have, and I want us to graph length versus area. Okay, so we have length, this second column here, and we have area, which is the last column. I'm just going to rewrite it into Desmos to see it as a graph. 9, 16, 21. Okay, this looks very much like a parabola. So I know that this is a quadratic, possibly a quadratic relation. Remember when we did math models, we said that using technology, we can create a regression graph to trace the shape. So I'm going to trace it using the quadratic regression. So we have y1 is equal to ax1 squared plus bx to the 1 plus c. Now the r squared is 1, so I know that this is exactly following the graph, and this is definitely a quadratic relation. Okay, let's interpret our graph here. X, we graphed length. So I'm just going to label it. And this is length in meters. And our y-axis is area, and this is in meters squared. So we clearly see from this graph that our area will change based on the length. There is a maximum point that happens at 5, and the area is 25. So let's use this information, and we're going to answer the questions based on our graph and based on what we know. So in this past example, we had a perimeter of 20 meters. Now, if we know the length, how can we find the width? Write an equation to show the relationship between the length and the width. So I'm going to first write out my general equation. I know that perimeter is equal to length plus width plus width. So I can simplify that to say perimeter is 2 lengths plus 2 widths. Now, I'm going to substitute in here 20 because I know that the perimeter was fixed at 20 meters. So let's say we know what the length is, how can I find the width? I would just substitute my length in here and I would rearrange the equation to solve for width. So now write an equation to show the relationship between the length and the width. So I'm going to rearrange it so that I have W is equal to. Okay, so 2W is equal to 2L minus 20. Then we can say W is equal to L, 2L minus 20 divided by 2. Or we could simplify and say L minus 10. Doesn't matter. Now let's say we're dealing with our area now. Based on the equation that we developed, write an equation to calculate the area, but we're only going to use the variable L. So we know area is equal to length times width. But in this case, I know that width is equal to 20L minus 20, or 2L minus 20 divided by 2, or we could say L minus 10. So let me substitute in what I have here. So I could say area is equal to length times 2L minus 20 divided by 2. So when I have this, I can put this into a graphing calculator program to find out what the maximum is. Okay, so either way is fine. So we can simplify it to this. Now I'm going to go to the next page, which is a graphing calculator page. I'm going to insert this into the graph. However, instead of using A and L, I'm going to use X and Y. Oops. Okay. This is actually the graph that it creates. So we have actually solved for it. We've graphed it already. Okay, so based on the parabola in your graph, what's the maximum area? Okay, so we have the vertex at 512, where X and Y means length and the area. So we know that the maximum area is 25 meters squared. And so the dimension would have to be we know that the length is equal to 5 meters. And when we have 5 meters, we can substitute this into here to find our width. Shoot, okay, sorry, I made a mistake here. This is 20 minus, 2L minus 20. Yes, okay. I made a mistake rearranging. The rearrangement, I moved plus 2W to the left side, so it's negative 2W. So I have minus 2, and then this becomes negative L plus 10. Okay, let's rearrange, sorry. Okay, so for us to find the width, we're going to use the equation that we've created. We know that the width is 2L minus 20 divided by negative 2. We're subbing in length is equal to 5. So we have W is 2 times 5 minus 20. Divided by negative 2. So that gives us positive 5. So the dimension 5 meters by 5 meters. Now what we just did here is a long way around the question because we already did the question using our manipulatives to find our answer. But I wanted to show that there are two different ways. We can use algebra to solve. We can use a graph to solve. And like in the video, we can use a trial and error method. Okay, so the conclusion that we can make from what we just talked about is that a square will always give us the maximal area. Now, if the square always gives us a maximal area, then we can use this principle to help us solve questions. So what are the dimensions of a rectangle with a perimeter of 20 meters and a maximum area? Now, one thing I know is the rectangle that produces a max area is a square. So that means I'm going to have the perimeter is equal to side plus side plus side plus side, or I can say 4 sides. Okay, so if I substituted that in, I have 20 is equal to 4s, and s is equal to 5. So that means if I had this issue, what's the maximum area? The area is going to be length times width, and I have 5 times 5. Sorry, this was, I should have picked a different number. I'm not sure why I did 20 because it's exactly the same as the example before. Now let's take a look at this one. Let's say I have a perimeter of 87 inches. What's the dimension for the rectangle with the maximum area? What is the area? So once again, we know that the rectangle is a square. So because it produces the maximum area, I know that my perimeter of a square is 4s. So I have 87 is equal to 4s. And S is 87 divided by 4, 21.75 inches. So what's our maximum area? Area is length times width. Okay, so 473.6. Okay, I'm going to give you a little bit of time. On the next page, you are going to solve or practice solving for this. So we have a fixed perimeter. I want you to find the maximum area. You need to find the dimension and the area. I'm going to pause this and give you 4 minutes to work on this, and we'll take it up shortly. Okay, let's take these up. For each perimeter, what are the dimensions of the rectangle with the maximum area? What's the area? Now we know that a square will always give us the maximum area for a limited or fixed perimeter. So I'm going to divide it so that I know the side is 10 centimeters. Area is going to be 10 times 10 or 10 squared. Okay, so the dimensions 10 by 10 centimeters. Our second one, 25 divided by 4. That gives us 6.25. The dimension 6.25 by 6.25. And our area is equal to 39.06 meters squared. Our dimension here, 27.5 feet by 27.5 feet. And our last one, we have our dimension of 186.25. Okay, I'm going to round it to 1 decimal spot. Right, so now that we have practiced our first principle, let's take a look at another example. Now this time, our example, we have a fixed area and we want a minimum perimeter. So let's say we had 36 1-meter squared tiles, and you want to make the largest patio with a minimum perimeter. What's the dimension of this patio and what's the perimeter of it? So the constraints that we have 36 1-by-1-meter tile. The area can't be greater than 36 meters squared. So we're going to watch this video, and we will fill out our chart again. Okay, so our first scenario, we could place all the tiles in one row. So we would have, if I just count the outside edge, I would have 36 units on the outside and the width of 1 unit there. Okay, now perimeter, remember perimeter, we have to take 2 times the length plus 2 times the width. So I have 72 plus 2, that would be 74. Okay, our next one, we could line up all of the tiles so that there are 2 rows of 18. Okay, so 2 rows of 18. My perimeter, 18 plus 18 plus 2 plus 2, that would be 40. Okay, now what if we put them into 3 rows? I now have 12 for the length and 3 for the width. So let's add them up. 2 lengths, 24, and 2 widths, that's 6. Gives us 30 meters. Okay, we can put it into 4 rows now. We have 4 rows of 9. Our length is 9, width is 4. Perimeter, 9 times 2 is 18, plus 2 times 4 is 26. Okay, now if I tried it with 5, it doesn't work because we actually have to have it as a perfect rectangle. This doesn't give us a rectangle because we have this one piece that's just kind of hanging out. So it doesn't work. All right, let's try another one then. Okay, this one I now have 6 units and 6 units. I have perimeter of 24, and I got that by 6 times 2 plus 6 times 2. Now we can continue creating other rectangles, but everything will just end up being the same, except the other direction. Okay, so I'm going to refill in the chart with the reverse. Okay, so clearly we can find the minimum perimeter. And once again, it's the square that gives us the optimal value. Okay, so let's do this the algebraic way too. You know that the area is 36 meters squared. If you know the width, write an equation to find the length. So I know that area is equal to length times width. In this case, I have 36 is equal to length times width. So if I want to express it as an equation to find the length, I could say length is equal to 36 divided by width. Now, using the equation that we developed in part 1, use it to calculate perimeter. So remember, perimeter is equal to 2 lengths plus 2 widths. Now, instead of writing length, I'm going to write 30 divided by W, wherever I see the L. So I have perimeter is equal to 2 times 36 over W plus 2W. So this is a bit of a weird looking equation because our variable's in the denominator. But once I have this, I'm going to take this equation and I'm going to put it into my graphing calculator. Now remember, the y coordinate or the y axis is represented by perimeter and our x is representing width. So let's write it down. Y is equal to 2 times 36 over x plus 2x. So where y is equal to perimeter and x is equal to width. Okay, we've graphed this. It's not in my field of view, so I'm going to scroll out to see if I can find it. And yes, I do see this. This is actually a graph called a reciprocal function. You don't need to know the name for that, but it does look kind of weird. It's not a typical parabola. In fact, it's not a parabola. But we do see where this minimum is. We have a value. So let me add my axes. So I'm talking about width, and then the y is the perimeter, and this is in meters. So the minimum that we have is 6 and 24. Okay, so let's interpret that. What is the minimum perimeter? Well, we know that perimeter was represented by my y coordinate. So that means the minimum perimeter has to be 24 meters. Okay, what's the dimension for the minimum perimeter? Well, let's take our width and we're going to substitute it into our length equation to get both. So width is equal to 6, length is equal to 36 over W, or we could say 36 over 6, which is 6. So our dimension is 6 meters by 6 meters. Okay, so what that tells us is, once again, if I have fixed area and I want to know the perimeter, a minimum perimeter, we also are working with a square. So because I'm working with a square, I can use what I know about squares to answer, to solve for problems. So for example here, I have a rectangle with an area of 45 meters squared. It has a minimum perimeter. What's the dimension of the rectangle and what's the perimeter? Well, first of all, I know that the area is 45, but I also know that a square is equal to side squared, or I could say length squared, or I could say W squared. So let's find the side. 45 is equal to side squared. Square root of 45 is equal to S. And the side that we're working with is 6.7. So the perimeter is 4 times 6.7. Okay, let's take a look at this one. We now have 169 square inches, a rectangle, and it has a minimum perimeter. Find the dimension and the perimeter. So once again, area 169. I know that I need to get the square root of that in order to get my side. So side is 13. And my perimeter is going to be 4 times 13. And we have 52 meters. So 13 inches by 13 inches. Area is fixed at 169, but perimeter is 52 meters. Okay, I'm going to give you a moment to work on slide number 11. Slide number 11 is practicing using this principle. Okay, let's take these up. Since these are all given an area and the area is fixed, for us to find the perimeter, we need to go backwards to get the square root of the area so that we can find the sides. So side of this one is 9, dimension 9 meters by 9 meters, and our perimeter is 36 meters. Okay, this one is not going to be a nice number, which is fine. We're going to have 15.81 inches. So our dimension, 15.81 times 15.81. And the perimeter is 63.24 4. Okay. Now let's go on. What if we had other constraints? Because so far, the two situations that we've looked at is we've looked at getting a rectangular area, with a fixed area and variable perimeter, or a fixed perimeter and variable area. Now, sometimes we don't have to fence in all 4 areas. Let's look at this. Like, let's say we had a beach and we just need to fence off a rectangular area where we have 2 sides and the deep end. We can't enclose the shoreline because we want people to be able to come in from the beach to the swim area. So in this case, we have 12 segments of floaty fencing to section off a swimming area. What's the maximum area that the lifeguard can create? So I made another video. We're going to watch this video and then fill out our chart again. We've got a fixed perimeter this time, and the area can change depending on how we place it. Okay, so in this case, we have a length of 10 and the width of 1. Length of 10, width of 1, the area is 10 meters squared. Okay, let's do another one. We now have 2 for our width, and this is a length of 8. Area of 16. Okay, this next one, I've got a width of 3, length of 6. Okay, we have 4 by 4 now. This is 16. Okay, 2 and 5, it's perimeter of 12, but it'll be 10. 2 and 5, 10. Okay, so we've filled out our chart. What we've done is we've used the manipulatives to build it out exactly. Now we call this method trial and error because we're kind of trying and seeing which one gives us the biggest one. Now you'll notice that the square no longer gives us the largest area. In fact, this one does. A length of 6, a width of 3 gave us an area of 18. So when I'm only needing to fence in 3 sides, a square won't cut it anymore. We actually want a rectangle. And the relationship is a length that is double that of the width. Now let's solve this question a second method. So instead of doing trial and error, I want to do this algebraically. So remember how in the previous questions, we wrote 2 equations and we expressed it as one variable. Then we graphed it to see where our minimum or maximum area was. So first, let's write an equation for the perimeter. Now, because this is a three-sided structure, I know that I have 2 lengths plus 1 width. So I can simplify it to P equals 2L plus 1W. Now, if I were to talk about the area now, area is still length times width. But because I've got 2 of these, I do need to combine it into one equation. So I'm going to combine it by rearranging it so that I only have one variable. Okay, sorry, let me substitute in my fixed perimeter. I know that in this case, the perimeter has to be 12. So I could say that I know negative 2L. Sorry, let's rearrange this for length. Negative 2L is equal to 1W minus 12. And the length is equal to W minus 12 over negative 2. Okay, so substituting it into this equation now. Area is equal to W minus 12, divided by negative 2 times W. So I need to put this into my graphing calculator to see what it gives us as the minimum. So we have y is equal to x minus 2 . Sorry, is that the equation that I have? W minus 12. Okay, we've got our parabola. Our maximum value is 618. Now, what does that tell us? We know that y is representing the area and x represents the width. Okay, so we have you know what I just noticed? I messed up on this. I did the opposite. The length was 1 and the width was 10. 2, 8, 3, 6. Okay, so maximum, that means our width is 6 meters. The length, we can substitute it in here to get 3 meters. And our area is 18 meters squared. So we did this without using trial and error. We did this using all algebra. Now let's try another question like this. In this question, we have a rectangular garden has to be fenced in using the wall of the house as one side of the garden. The garden should have an area of 40 square meters. Determine the minimum perimeter and the dimension of the garden. And we're going to use algebra to figure this out. So first of all, what is our fixed variable? Is it area or is it perimeter? So it's told us here, the garden should have an area of 40 meters squared. So we can't change this. That means our area has to be fixed. So since we know that area is fixed, let's first write an area equation. So based on this diagram, our area is going to be length times width. But we also know that this is 40. So 40 is equal to length times width. And I could rearrange it so that length is equal to 40 divided by W. Now write another equation for the other variable. So now we're going to write a perimeter equation. So in this case, perimeter, I have W plus L plus W. Perimeter is equal to 2W plus L. So this is W, W, and L. So let me combine these two by substituting 40 over W into the L. Great. We've got this equation here. I don't know what it looks like off the top of my head. So I'm going to consult my graphing calculator, find the minimum value so that I can find the perimeter. Now, what I do know is that in this case, my y-axis will represent perimeter and my x will represent the width. Okay, so y is equal to 40 over x plus x. 40 over x plus 2x. Okay, so let's round this. We'll say the minimum is 4.5 and Okay, so now that we found this, what's the interpretation of this? Well, we know that the Y is representing the perimeter. So the perimeter of the garden is going to be 17.9 meters. Dimension, we know that the width is 4.5, and now we have to substitute it into our equation to get the length. So we'll round it to 8.9. Okay, so the dimension, 4.5 meters by 8.9 meters. The area was fixed at 40 meters squared. And then our perimeter is going to be 4.5 plus 4.5 plus 8.9. So 17.9 meters. Okay, so this one is a little bit more tricky. But what we've done in all of the examples so far is we've expressed things using both our area and our perimeter equation. This way, we're able to juggle them around until we get the value that we need. So slide number, we'll skip the extension for now. Slide number 16, I want you to try this on your own. You're going to answer this question, and we're going to write two equations for it. If you get stuck, I will be popping in to check on your slides and writing comments on it. So give this a shot, and we'll take this up in a little bit. Okay, let's take this up. So this question, we have a rectangular section of a field is to be fenced because one side of the fence is bordered by a creek. Only 3 sides need to be fenced. So the fence section should have an area of 60 meters squared. Draw a diagram, write an equation to determine the minimum perimeter and the dimension of the fenced area. Graph it and interpret the results. Now we know that the fenced area has to be 60 meters squared. So that means the area is not going to change. So our area is 60 is equal to length times width. Now I could change that to say that length is equal to 60 divided by W, and it's still meaning the same thing. So for the other variable, let's combine it with the equation. So, before we do that, let me draw my diagram. Okay, so this is my creek. And I'm gonna have a fence, fence, and fence. Let's call this width. I'll call this length. Okay, so our perimeter is equal to 2W plus 1 length. Now, when I substitute this in, I have perimeter is equal to 2W plus 60 over W. So I need to put this into a graphing program to figure out what it is. So let me define my y-axis is representing perimeter and x-axis is representing the width. Okay. Our minimum here, 5.47, let me round it to 5.5, and 21.9. So what that tells me is my x value is the width, y value is my perimeter. So when the width is 5.5, you get minimum perimeter at 21.9 meters. Okay, so the dimension then, sorry, since I know that length is equal to 60 over W, I would get 60 over 5.5, 10.9. So the dimension 5.5 meters by 10.9 meters. Okay, so slides number 17, 18, and 19 are a few practice questions for you to do. Tomorrow, we're going to continue on this topic and investigate different shapes as well. Okay, so I'm going to let you work on that for the rest of the period. I will be here. Please let me know if you get stuck.